Hi, welcome back to the breadboard. We have another mailbag opening to do here. I have a couple of, well, I had 3 basic sets of mailbags that I want to go through. This one deserves its own video. It's, as you can see from the packaging, it's from LDO Motors. A little while ago I reached out to them about me doing a second build because my first scrappy build is pretty much everything that I already had laying around at home, but I wanted to do one and hopefully with the help of some sponsors or contributors to the project. So I'm doing a 300 by 300 Trident build, which is another Voron. And when I reached out to LDO Motors, they kindly came back to me and said, we'll send you a few parts to help you with the build. So this is the package that's arrived, and let's go have a look, see what they've sent me. Okay, I've pulled everything out of the box, so we don't have the box to contend with. Anyway, what we have here is a Nighthawk Stealth Burner toolboard. So that's the Stealth Burner is one of the designs of the head for the Voron printers. What LDO Motors has sent me is actually a USB umbilical cable and their Nighthawk SB is a USB attached board versus a CAN bus. Now the cable that we have here that goes with it is a USB cable. Now it doesn't really matter whether it's USB or CAN bus. I really probably shouldn't call it a USB cable because you're putting 24 volts down here, and if you connected that to a USB device you'd blow it up in no short terms. But what they've got is a cable designed to take USB data. So the 2 smaller wires in here will be the USB data plus and data minus, and then you have the red and black wire, which is going to be the 24 volts to drive your tool head. Okay, and there's nothing wrong with that as long as you don't think that it's a fully USB compatible cable. It isn't. It's just carrying the USB data lines along the cable, and it's designed to be flexible for putting in cable chains or as an umbilical connection on your printer. So we have a 24 volt adapter wire to go from your printer to the little box that little card which I'm about to show you, which is this. What you have here is from your Raspberry Pi you would connect the USB into here and your wire your 24 volts in here, and what it does is it adapts it to the umbilical cable here and brings it up to the far end. This has also got an integrated fuse with it, so if there is a problem at the far end it'll blow the fuse rather than cause any additional damage. You get a USB cable to go from your Pi to the controller, also to program it if you need to, I would imagine. And then we have the tool head part itself, which actually has a lot of things on here. It has a RP2040. It has a stepper driver on board. It has an accelerometer on board, as well as fan controls and things. All right, so all of these things are in here. It's a Trinamics driver right here for the stepper drive. So all of this plus a couple of fans, thermistors, is all handled on this board, and it's USB attached. There's a lot of argument about whether USB or CAN bus is the better one to use for 3D printers, but CAN bus kind of tops out at about 1 megahertz. USB goes up way beyond that. So that's what the Nighthawk toolboard is for a 3D printer. Saves you a huge amount of wiring and hassle. There's a lot of people get issues and troubles trying to configure a CAN bus on a Raspberry Pi to get working properly. USB, it's just native to it, so from that perspective it's far simpler. The other parts that you get with it are all the nuts and bolts and screws, crimps for connecting it all up, because obviously all of your fans and everything else you need to plug it into the tool board, so they've given you the crimps and everything else you need with the right plugs and screws to mount it, to be able to achieve that, which is really nice. Thanks to LDO for sending me this. So the next thing they sent me from an electronics perspective is their Leviathan controller, which is awesome. I'm very pleased to see this. My Voron 2.4 that I'm building, I'm using a Pico Octopus controller, which is also an 8-channel controller, but this one has actually been very specifically designed in collaboration with Voron printers to drive and work with Clipper, etc., etc., etc. So this is kind of a special board. Lots of parts in here. Let's just pull them out of the board first, and then we'll go through them. Again, crimps. I won't bother opening these up, but crimps and standoffs and things like that. Jumpers, and the Leviathan board itself. When I read about this board, I was very impressed, and when I looked at the specifications too, I was even more impressed. I've seen a lot of 3D printed control boards, and they lack in some way or the other. This one has been very specifically designed for what Voron folks tend to do with their Voron printers. So this is the Voron main control board. Beautiful artwork. This big piece of empty space here, there's nothing on the other side. This is actually for a Raspberry Pi to go into. Let me just grab one for a second. Okay, so this is a Raspberry Pi 3B Plus, and what you would do is basically with the standoffs, it would mount right in there. And then they actually provide, I'll show you in a moment, a jumper which will jump from here straight to this connector and make all the communications and power connections and everything you need for the Raspberry Pi. So it makes the whole connection system far simpler and more reliable. We have fused inputs, so we've got power inputs at one side. We also have an additional power input here. Now if you notice, we've got 1, 2, 3, 4, 5 drivers here. There's the 5 outputs for stepper motors, and then we have an additional 2 right here. Now if you take a Voron 2.4 R2, then you've got 4 stepper motors for the Z-axis, so 1, 2, 3, 4. You then have 2 stepper motors for your core XY drive, which normally ends up needing to be driven harder because that's the bit that has the head flying around. And almost every Voron builder I've seen has decided they want to push that to the limits to get faster prints and things like that. The Z moves once a layer. The core XY mechanics of X and Y moves all the time. So you've got bigger heat sinks, you've got 5160 drivers as opposed to 2209, I think they are here. Anyway, they're all Trinamics drivers. These are the higher power ones. The other benefit you've got is that having these two powered from a separate input, it allows for you to run up to 48 volts or more to drive these 2 steppers. Now, stepper motors, more voltage, which means potentially more current, allows you to go faster on your stepper motors and still maintain torque. It doesn't give you more torque for the same limit of what the stepper motor can take, but it allows you to go faster without losing the torque by having more voltage available. Plenty of capacitors for smoothing and things like that. Over here you've got the main ARM processor controller for the whole of this part of the printer. It does have USB connection as well, although the Pi would normally connect through this connector. So if you were going to use it with a different, other than a Pi, then you could connect it through the USB. Lots of fans and thermistor inputs along the edge here. We've got different interfaces to go to a display, and we also do have a CAN bus output on the end here as well, if that's how you want to connect. The other nice thing that seems to be in here are these 3 brick looking objects. They're not actually capacitors. I believe these are DC to DC converters, because this is providing 12 volts, 5 volts and 3.3 volts obviously for the core, but you're feeding it with 24. So it has enough to drive several amps for a Raspberry Pi. That's probably going to be this bigger one. The 12 volts and 3.3 volts are probably going to be these smaller ones. There may be an additional bit of circuitry on here. When we go for a full review of this, we will look at the schematics and everything else and go through it. But now that's all I'm going to talk about with the board itself. We have an adapter, looks like, USB. Let's have a look at this. It comes with cables so that you can go from a Raspberry Pi 5, 4, or 3. So here's another adapter cable, USB, down to the connector. So if you have a Pi that isn't compatible with that, or maybe a different brand that's not compatible with that jumper, you can actually use the USB input on the side of the board. Let's grab the board a second again. So here's the board. All right, we've got the USB connection right here, and with a Pi on top, right? This would allow you just to jump her right in there and just drop it into the USB-C connector here so that you can get the communications going via USB instead. And the other package that's here are different jumpers that will plug in for different Pis, I would imagine. Yeah, this one's for a Pi 5 and it's got a fancy little ribbon cable here for something. Not sure what, but there's a little ribbon cable, like a flat cable, not a flex cable, like this kind of cable. Here, though there isn't one in the packaging for it that I can see. We've got the USB-C lead there. This is the jumper that will go from the Pi header down to the board, make the connection. Suffice to say, they got you covered with all the different Pis that you might want to connect. So that's the Leviathan board designed specifically for Voron in collaboration with Voron and LDO motors. Awesome little board. Glad I've got it for this build. So what's left? Okay, the thing that Voron is more famous for are their motors. And they kindly sent me every motor I need to build a Voron, Trident Voron. So these three are exactly the same. So I'm just going to move two aside for a second. We'll just open the one up. So we open this up. What we've got is a Z motor with integrated lead screw and the relevant nut for it as well. So there's three of these, one, two, and this one. And because Voron Trident, the Trident part, in giving a hint away, only mounts the bed at 3 points, and it will do automatic bed leveling by varying the points of those motors independently so that you can get the bed flat to the print head, which is really cool. So I've got three of these been sent to me, and these are the approved ones for Vorons as well. We've got three more motors here. Let's deal with these next. I will circle back to the controller in a moment just to cover something off here. So here, these are much beefier stepper motors. And if you remember what I was saying about the controller, you've got those two 5160 stepper drivers that are included on there, which you can put more volts on. Well, what Voron have in their kit are these beefier motors for driving the Core XY mechanics of it. Now this, you can get a kit for the Voron 2.4 R2 as well. The difference is you won't have these three integrated shaft motors. You would have four motors more like this, but maybe the same shorter ones, more like this, the size of the motors that are in here, but without the rod attached to them or integrated into them. So these are much more powerful motors. The voltage for stepper motors is not defined in its specifications. Where you do see it, it might say 3 volts at maybe 2 amps. And that's because of the DC conditions of the motor, not because of the dynamics of the AC and induction and how all that stuff works. I'm not going to go into it now, but suffice to say it's a little more complicated than just, 24 volts into the motor. Oh, that's going to overload it. It's way more complicated than that. Anyway, these are much more powerful for driving your Core XY mechanics. You can go really fast printing. That's one of the key selling points of Voron printers, is how fast they can print. The restriction is really your hot end and how fast you can melt plastic. Anyway, that's the motor. We've got two of these. There's the other one. And they give you a nice long extension cable. On a Trident, the bed moves up and down, and the gantry that supports the head is fixed. So you could put heavier things on there and not really worry about it too much. Anyway, that's those two motors. There's one more motor here to show you. So that's that. And that is the last one. So I mentioned that there are, on the controller, the one thing I didn't mention with this is you've got, in the case of the Trident, you've got Z, 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 you've got X and Y, or A and B, usually typically with a Core XY. So I've got two more unused stepper motors here. So one of these would normally be used for the head. But we're using a USB tool head, so we're not actually going to be using these two. So we'll have ZZZ, A and B, and these two would end up unused. Now, if I was having a enraged rabbit carrot feeder or something, I could potentially use these two for driving something like that. I probably wouldn't. I'd probably still connect that via a separate CAN bus or something, but you could. So when you're doing that, either way, the tool head needs a motor for the extruder. So what they have is in Voron's designs for the Stealth Burner and others, they have a few different tool head designs. They have a little pancake motor for it. So this is the LDO motor's pancake motor for the extruder. Nice long cable. Now obviously this cable is long enough to go all the way to the electronics bay on the controller board, but what we'll be doing is probably clipping it off real short and crimping on its own connector so that it can connect directly into the tool head board. You'll see all that as we go through the build. So that completes all of the motors that LDO has sent me. Again, big thanks to LDO Motors. I'll provide links in the description for where you can get these for yourself. But yeah, very, very happy about this from LDO Motors. Anyway, that's it for the unboxing. I look forward to integrating this into my Trident build, and I will see you on the next video. Bye for now.